Okay, here we go. All right. Within generally physics, but definitely calculus, we have different types of functions that represent things of motion. So today what we're going to have a particle, and the particle is going to move back and forth along the x-axis. So it's as simple as this, okay? I've got the x-axis, just a number line, and the particle might start here, it might come back here, and then move over there, and then might move back over here again. Who knows, okay? It's just moving back and forth, okay? Its position or its location, we're going to use the variable s for that. And why s, why not p? I don't know. I probably would use p, but s is what's used. Maybe there's an s in there. I don't know. Okay. Now, here's what's really neat. We have position, but then we have s prime. The derivative of position is actually your velocity. So the derivative of position is velocity. Now, some people are wondering what the heck is velocity. Velocity is basically the same thing as speed. Okay? The difference is velocity can be both positive and it can be negative. Okay? So for example, right now, my velocity is positive because I'm moving to the right. Right now, my velocity is negative because I'm moving to the left. Got it? If you're moving up, do you think your velocity is positive or negative? Positive. And you're moving down? Negative. So speed, do we ever talk about our car traveling at negative 35 miles an hour? We always talk about the positive, right? So speed is the absolute value of velocity. Okay. The second derivative of position is the same thing as the derivative of a velocity, which is the same thing as acceleration. So, we're going to have you describe my motion. You're going to be tempted to maybe laugh because I'm going to look stupid, okay? Don't focus on how dumb I look, focus on what's actually happening. Ready? Describe my motion in the 2 times that I do this, okay? So I'm going to move that way. Okay, that's my first motion. Here's my second motion. Okay, somebody tell me, how would you describe what I was just doing? First time. I was speeding up, and the second time I was true or false. Each time my velocity was positive. True, I was moving in the positive direction. True or false, each time my acceleration was positive. False, which time was my acceleration positive? The first one, I was accelerating, whereas the second time I was decelerating. Everybody see that? Good. So acceleration can be both positive and negative as well. It's the rate of change of the velocity. All right, you're set to go. Question A. It says the equation of motion is given where s is in meters and t is in seconds. This is our position function. Can somebody out there please tell me the velocity at time t? How does velocity compare to, what's that? Good. We all good so far? We just took the first derivative, right? Now it says, what's the acceleration at time t? Is everybody okay? Letter C says, when is the velocity positive? So what I'm going to do in order to determine when the velocity is positive is I'm going to look at the graph. If I consider this, its shape, can I get rid of this now, please, so I can have room? Okay. So I'm going to get rid of that. So this function is going to be the same thing as 3t times 6 minus t. So everybody okay with that? I just factored it. So what shape does that make if I were to graph it? So the p rhymes with parabola. Parabola, right side up or upside down? Upside down, a negative 3t squared. So as I graph this, it is an upside down parabola. It's going to go through 0, and it's going to go through positive 6. This is the graph of v of t. It is the velocity function. First of all, do you see that it's a parabola because it's squared? Second of all, do you see it's upside down? Because the t squared is negative. Okay? Now if I factor it to this, I can see that the solution of 0 and 6, that tells me where it crosses the x-axis. So the question is, where is this positive? Where is the velocity positive? What does it mean for a graph to be positive? It means it's above the x-axis. So is it above the x-axis here? So we do not include the values from negative infinity to 0. Is it above the x-axis here? So we do include the values from 0 to 6. Is it above the x-axis here? So we do not include those values. So it says, when is the velocity positive? The velocity is positive from 0 to 6. I just want to be clear that let's not do any brackets, okay? Let's not get into the discussion about brackets. It doesn't seem that the AP exam really ever has a point where it really delineates between brackets and parentheses. And so for our problems, if you notice any brackets on the answer key, don't really pay attention to it. It's not that big of a deal. We okay with that? All right. The next question says, when is the acceleration positive? Can somebody tell me about the graph of acceleration? It's a line, right? Yeah. In fact, if we, I could actually do something pretty nice with this line. What's the slope of the line? Is it going to be going up or going down? And in fact, if you just factored out a 6, you get 3 minus t, right? So where's this line going to cross the x-axis? It's going to cross at 3, right? So I'm now going to draw an acceleration graph. The acceleration graph is going to look something like that. Notice how it sits above the x-axis and it sits below the x-axis. It says, when is the acceleration positive? That's wherever the graph is, above the x-axis. And that'll be from negative infinity to 3, right? Only in context of this problem, I just want you to understand, what does t represent in this problem? Time. Do we talk about negative time? We don't. So, we're just going to, we won't refer to negative time, so that will not be part of our answers. We'll just say 0 to 3, okay? From 0 to 3. How are you so far? We good? Okay. Now we get to the next piece. All right. You know what? No, I want to pause. I want you to take out your homework. I want us to look at the first problem, and I want us to try A, B, C, and D for that first problem. Good. So now I want you to watch my motion, okay? So the question is, when is the particle speeding up? When is the particle slowing down? And then we're going to do the distance piece. So you tell me, am I speeding up or am I slowing down? Speeding up. My velocity was positive or negative? Positive. My acceleration was positive or negative? Positive. Okay? Now, speeding up or slowing down? Velocity positive or negative? Acceleration positive or negative? Okay, good. Speeding up or slowing down? No. Ready? Speeding up. Velocity positive or negative? Negative. Acceleration positive or negative? You're thinking positive because you're thinking of me speeding up, right? But acceleration has direction. Acceleration has direction. So was I going in a positive direction or negative direction? I was going in a negative direction, okay? So acceleration at that time was also negative. Now I'll do slowing down, okay? And see, this should make sense to you, okay? So here I go. I'm going to be slowing down. You see that? When I was first starting, I was slowing down, right? Was the velocity positive or negative? Negative. Was the acceleration positive or negative? The acceleration was positive. It was trying to bring me around, you know what I'm saying? So what do you notice about speeding up compared to slowing down? If they're the same signs, you're speeding up. If they're opposite signs, you're slowing down. You see that? Good. So here we go. Let's figure this out. What I'm going to do here is I'm going to make just a little chart. I'm going to put some important values on my chart. I'm going to look at velocity on top. I'm going to look at acceleration on bottom. Okay? I start at time 0. When does my velocity change? When does my acceleration change? At what values do my velocity and acceleration change? 3 and 6. Okay? Everybody okay with my chart so far? The velocity from 0 to 3. Is the velocity positive or negative from 0 to 3? Is the velocity positive or negative from 3 to 6? Positive. I'm not looking at the slope. This is the velocity function. Is the function above or below the x-axis? So therefore it's positive. Is the velocity positive or negative from 6 to infinity? Negative. Above, below, right? Okay, then we saw our other graph. Our other graph looked like this. Right, our acceleration graph that I drew, kind of erased it by accident. Okay, from 0 to 3, was our acceleration positive or negative? It was positive. From 3 to 6, is the acceleration positive or negative? Negative. And from 6 to infinity, is it positive or negative? Negative. So the question is, when is the particle speeding up? When are the signs the same? 0 to 3, union with 6 to infinity. When is the particle slowing down? That's when they're different. When are they different? 3 to 6. Does that make sense? Turn to your problem that you're currently working on and see if you can figure out when it's speeding up and when it's slowing down. Go. Good. You're doing excellent work. Let's consider the last piece. It says, what is the distance the particle has traveled over the course of 8 seconds? Over the course of 8 seconds. Okay? So, what you need to do in this situation is consider position, which is your S function, and you need to consider v of t, which is your velocity function. Okay? And these are the important things we want to think about. And by the way, you guys you're doing a great job. Okay, this is not easy, and trust me, as I can see into the future, these problems will be consistently easier as we go over them. And what you're seeing here, it is the most common free response question you're going to see on the AP exam. So we will see these problems continue, and they will only be easier as we do them. You're doing a great job getting through the first time. I start here. Somebody give me a distance. What's the distance from me to the door? Approximate. 10 feet? 15? 16? We're going 16, okay? All right, 16. I like 16. Okay, I can both long jump that. Here we go. Okay, so I'm a particle, and I'm going to move. I'm going to move from here. Somebody tell me the distance I've traveled. 32. Everybody agreed? Yes. What's my displacement? Meaning, how far am I from where I began? 0. Displacement, 0. However, distance, 32. That's important, isn't it? Tell me about my velocity during my travel. It was positive, then it switched to negative, right? It's important to know when your velocity changes, because that means you change direction, isn't it? So that's why we have to think about when we change direction. So let's figure these pieces out in this problem. When was our start? When did we start? What time do we start? 0. What time do we end in this problem, does it say? And at what time do we change direction? That's when the velocity changes. At what time does the velocity change? This is my velocity function. When I say change, what I mean is when does it change from positive to negative? At time 6. We see that? The velocity changes from positive to negative. That means that the particle, right now, it's moving to the right. And then at 6 seconds, it starts moving back to the left. That's what this is telling us. Okay? So at time 6, I change direction. So what I want to do at this point is I want to figure out where the particle is at those times. So if I want to figure out the location of the particle, do I use my position function? Do I use my velocity function? Or do I use my acceleration function? I'm wondering where I am. Everybody see I go to position? If I plug in the time, that will tell me my location, correct? So let's figure out where we are at the very beginning. I plug in a value of 0. When you plug in 0, you get 0. Functions, or the particle starts at 0. At what time do I change direction? 6. Everybody see that? Let's figure out where we are at time 6. To figure out where we are at time 6, where do I go? What do I do with 6? Plug it into my position. Then go to my calculator. And I go 9 times 6 squared minus 6 raised, 9 times 6 raised to the second power minus 6 raised to the third power. And I get 108. So right now, look at what's happened. We move from a position of 0 to a position of 108. Is that velocity positive, or does that mean velocity is negative if I'm moving to the right? Positive. And look at my graph. You can see that the function is above the x-axis. Excellent. Now, I changed direction at that point. Okay? It looks like I changed direction. I end at time 8. I want to figure out where I am at time 8. How do I figure out where I am at time 8? Plug in 8 to the function. So I'll do that same thing, except instead of 6, I'm going to put an 8 in its place. I get 64. That is the motion of my particle over the course of 8 seconds. I now want you to confer with your partner next to you and try to figure out if it went to 108 and then back to 64, what's the total distance traveled? Talk, figure it out, go. Anybody confident in an answer? Like you're like, you know what? I feel like we're right on. What do you got?
172.
I heard a 172. Let's figure out if we're right or wrong. What's the distance? What's the distance from 0 to 108?
108.
Everybody agree with that? And then what's the distance from 108 to 64? Well, in order to figure that out, I would have to do 108 minus 64. So I'll add on to that 44. Yes. Yep. So the distance from 0 to 108 is 108. Now I need to figure out the distance from 108 to 64. So I'll subtract those two values. And I get 44. Now I add them together. Okay. All right. Excellent work. We need to pause.